All right, this is the last section of Unit 5, and this is 5-8, applying special right triangles. Our objectives, we're going to justify and apply properties of the 45, 45, 90 triangles. We're going to justify and apply properties of the 30, 60, 90 triangles. A 45, 45, 90 degree triangle is one type of special right triangle. You can use the Pythagorean theorem to find a relationship among the side lengths of a 45, 45, 90 triangle. Okay, so let's draw a right triangle. And let's label our legs L and our hypotenuse H. And let's solve for our hypotenuse. So we're going to use Pythagorean theorem. And we're going to substitute in for our legs and in for our hypotenuse. Now, this is called a literal equation when you have more than one variable in an equation, but we can still solve it. Let's simplify the left side by combining like terms. We're trying to solve for the hypotenuse. So to find for the hypotenuse, we need to take the square root. Okay? So the square root of 2L squared is going to be L radical 2. So H equals L radical 2. So class, what this is telling us is that when we have an isosceles triangle, which we do because these two side lengths are the same because they both equal L, what do we know about these two angle measurements? They are 45 degrees. Because we have to have, because of our triangle angle sum theorem, we have to have 180 degrees. So if this is 90, then these two are acute angles, and if they're congruent, they have to be 45. Okay? So what we have here is our special 45, 45, 90 right triangle. So what we can do is we can say that when we have that 45, 45, 90, if this is 45 degrees and this is 45 degrees, you've got your leg length. Your hypotenuse is going to be that leg length times square root of 2. So that's your 45, 45, 90. So let's look at that theorem. We just proved it. Okay? So it's letting you know that your two legs have a measurement of L. Then your hypotenuse is L times the square root of 2. All right, sorry about that, guys. Okay, so what we're trying to solve here is we're trying to solve for x, and x is our hypotenuse. Well, if this angle is 45 and this angle is 90, then you know this angle here is 45 because of your triangle angle sum, right? So we have an isosceles triangle. So what we can say is that your hypotenuse from your 45, 45, 90 is your length times square root of 2. Well, your length is the leg. So your hypotenuse is 8 times the square root of 2. That's it. Now, if you wanted to try to plug it all into the Pythagorean theorem and do 8 squared plus 8 squared, you're still going to get the same thing. But that's why we use these shortcuts, 45, 45, 90. You can immediately find out that the hypotenuse is 8 times the square root of 2. Okay, on this one, we have the hypotenuse, but we don't have the leg measurements. However, we do have an isosceles triangle because these two legs are congruent, and because of your isosceles triangle theorem, You know these two angles are congruent, therefore they're 45 degrees. So we can use our 45, 45, 90, okay? Where our hypotenuse equals the length of the leg times square root of 2. Hypotenuse is given. The length of the leg is x times square root of 2. So we are trying to solve for x, isolate the variable x. So we need to divide by the square root of 2. This cancels out to 1, so on the right side you have x. We need to divide the left side by square root of 2. So you have 5 divided by the square root of 2. X equals 5 divided by the square root of 2. However, you cannot have a radical sign as your denominator. So to cancel that out, we can times this by the square root of 2 over the square root of 2. Well, why can we do that without changing the value of this? Well, what is the square root of 2 over the square root of 2? That's 1. Okay? So, x is actually going to be 5 times the square root of 2. And then the square root of 2 times the square root of 2 is the square root of 4, which actually is 2. So here's your answer. Okay, let's do another one. Okay, trying to find x. Well, we've got a right triangle. We've got these two angles that are congruent. They're reversed by the converse of your isosceles triangle. You know that this side right here is also 10 square root of 2. Because these are your, even though it doesn't look like it, not drawn to scale, not drawn, your diagram not drawn to scale, cross, so they're congruent. Okay, so we're trying to find the hypotenuse here. So your hypotenuse is the length times square root of 2. Length of one of your sides times square root of 2. Well, the hypotenuse is what we're trying to solve for, so let's substitute in x. Our length of our leg is 10 times the square root of 2. This is the length of our leg, and then we got to bring down the rest of this equation here. So let's simplify. So we have x equals 10 times the square root of 2 times the square root of 2. Well, this simplifies square root of 4, which just simplifies to 2. So 10 times 2 is going to give us 20. Okay, see if you can do this one on your own. Okay, I'm going to be quiet on this one also, students, and let's see you read this on your own and see if you can solve it on your own. I'm going to solve it quietly on the board, so if you get stuck on anything, you can look up here. Okay, if you got stuck on this, what you want to do is you want to add 10 inches to the hypotenuse. And you want to use that new measurement to try to find one of the leg measures. Then once you find the leg measure, you can find out the size of the square, which is going to be 33 inches. Okay, this is going to be the end of part 1. Part 2 will be coming up in just a minute.